Hi everyone, welcome back. In this video, we are going to learn about the view ref spectrum slash find peak step in the HR workflow. We are still using the pre-average data files we've been working on from the iodide sims. So at this point, you should have done MassCal, define reference spectrum, refining the baseline peak width and shape, a second MassCal, and now you are back along this onto the view ref spectrum. So let's click here and get into it. So when you click this button, two separate windows come up. One of them is called Review or Find Peaks using reference MS, and the other one is called the Peak List. So between these two windows, in here, you're going to be finding peaks using your reference mass spectrum, or you'll be reviewing peaks. And then in here, you'll either be building or refining some peak list. And any peaks that you find and develop and confirm and exist in your peak list here will become integrated when you do your batch fit. So everything in the peak list will be the high resolution peaks that you have upon the batch fit. Okay, so we are going to, let's start on the peak list for a second here to bring up that you might already have a peak list. One place that you could get a peak list is from another student in your lab or a colleague. Another spot that you get a peak list is from the knowledge base from Aerodyne and TOFWork. They have some base peak lists for different reagent ion chemistries. So if you are given a peak list and you want to try your peak list out, you can load a peak list from the text file up here. On the other hand, if you've worked really hard on developing a peak list, say you've done a series of experiments in the chamber or as I did like in the office space, maybe you've developed a peak list, you can save it to a text file, and the next time you're doing a new experiment, you can just load it in and just review instead of develop or build. Okay, now that we've gone over kind of some basic different approaches to this, we have to find our peaks. So we're going to this window, and this button right here on the far right, this will kind of bring us into what I think of as HR mode. It brings us all these options. And what we can do is if we're looking for a certain peak, we can jump to it here by typing it in and hitting enter. And so I'm going to 161 in this case because it's one of our larger peaks that's not our reagent ion. So I think that we might be able to fit this. And I also know what it is, so it's a bit cheating. But that's one good way to think of it. So it's already added a peak here because it's big. So what we can do is left click on it and hit composition isotopes. And when you do that, this should pop up on the right side of your window. Under name here, we have different atoms, carbon, hydrogen, oxygen, iodine, and nitrogen. We can add or remove atoms based on what we think we're searching for. But perhaps the most important thing is that you need to make sure that you have whatever makes sense for your ion chemistry to be included in here. So right now we're doing iodide mass spectrometry. So we need to have an iodine here. And we need to always have at least one. So I've put my one down there. And I'm really just searching for one. So you hit your low possible number and your high possible number. That's what this low and high represent. How many do you want to be searching for? I want every formula to show up below here with an I. So that's important. The other important thing is what is your overall ion charge? And because we're in iodide, it is going to be -1. So I set this to -1. So if I were instead doing PTR, I would want to ensure that I had the H at a low of 1 and my ion charge would be plus instead. So this is something to check right away. And then if I know that I'm not looking for something with nitrogen, I can get rid of the nitrogen by clicking on it. And now it's gone. And then I can research and nitrogen ones don't come up. And wow, now my possible answers are so much emptier. The next important thing I want to bring up on just our first peek to find is that Toffware for this composition finder, it does not know chemistry. It only knows math. So it's going to come up with different elemental formulas based off of math, not chemistry. So you need to ensure that the formula that you are planning to assign a peak is chemically possible. Toffware can kind of help you with this by helping you search for this formula on the NIST webbook, Google, Bing, ChemSpider. So if you're unsure of something, if it looks possible but you're not 100% sure, that's an easy way to search it. I just did that by right-clicking on the formula. You can also pop this table out and get some more information on these different results. So for example, double bond equivalent. Yeah, and then the next thing that you need to do is if you find a formula in the options that you think is viable, I think the big question is what is the accuracy, the ppm accuracy of that formula to the peak? And here, the hydrogen peroxide, the H2O2 that I want to assign, it's within 10, it's at about 5. And so that's really great for iodide sims. So I would feel really confident assigning this. So I'm going to hit assign. And as I do that, we could see the number, the exact mass, the 160.9, blah, 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 turned into IH2O2 minus. So now I've told Toffware that this is a peak that we know what it is. It is exactly this in high resolution, IH2O2 minus, and there's its mass, and I want it to be that. And so now this is on our peak list. And if we jump over to the peak list, we can see it there. And then some other peaks show up that are unknown, but we can get rid of those in a moment. There's something else I wanted to say about assigning peaks and accuracy. Yes, okay. So let's just pretend I was doing a chamber experiment and I knew 100% I injected some compound into that chamber, and I knew the mass of that compound and what it would form with that reagent ion, and I was at that peak. And the formula for that had a ppm of 200 or 400. That means something is wrong. I would definitely pause and hesitate and think before assigning that right away. One of the first questions could be, is my mass cal as good as I thought it was? Or am I totally off? So that's just something else to be aware of. So yeah, hopefully this is a good little intro to viewing and finding reference peaks. This is a big step, so I encourage you to explore it. And with all these little different buttons, you can hover over them and they will help you sort of understand all the different tools you can use here. And the last thing I'll show you is that when I added that 161 peak, using that nominal M over Q tool, we also added some unknown peaks that we didn't assign. You can get rid of them by clicking in that gray area and then hitting remove all visible unknown peaks. And now I just have the H2O2 minus that I already assigned. Okay, great. Good luck. I definitely encourage you to explore this step and the different sort of options and tools up here because there's a lot to learn and I can't cover it all in a quick 5-minute video. All right, best of luck. Thanks.